I put some ice in some soup. What's the final temperature of the soup? To answer this, I need to know the specific heats of the things involved in the heat transfer, alongside the latent heat of fusion of anything that changes from solid to liquid. So what I would be expecting is, as I put my ice into the soup, the ice should melt and change into liquid water. Here's all the values you need. Have a go before I start to solve. The central idea in this type of question in thermo is just the heat that is gained by one object is equal to the heat which is lost by the other object. Here is our expression for the energy which is gained by the ice. Notice that it's broken up into three different parts. The first expression denotes the energy gained by the ice before it starts to melt. This is the energy required to get the ice from -20 to its melting point of 0. The second term, ml, is the energy required to melt the ice. So this is where it undergoes a phase transition and it changes from 0 degrees Celsius ice to 0 degrees Celsius water. Remember, there is no temperature change in a phase transition. After these two processes have occurred, we now have 25 grams of liquid water at 0 degrees Celsius. The third term will allow us to find the common temperature or the equilibrium temperature with the soup. Using our first expression, we see it takes 1050 joules to change the ice from -20 to 0. Using our second term, we now see it requires an additional 8350 joules to make the ice melt. This is when it changes from 0 degrees Celsius ice to 0 degrees Celsius liquid water. In step 3, the liquid water now warms up as it continues to absorb energy from the soup. What we need to solve for is the final temperature of this soup water mixture. Do keep in mind in this step my Ti is actually 0 because the liquid water starts from 0 degrees Celsius. So the expression for the total energy absorbed by the ice is 1050 plus 8350 plus 105 TF, which gives us 9400 plus 105 TF. And what we're saying in this part is the energy absorbed by the water is equal to the energy which is lost by the soup. Recognizing from the question the soup started at 83 degrees Celsius, we end up with this expression. Now we're just going to group our TFs and solve. So the final temperature is 57.3 degrees Celsius. Your teacher might be targeting this question for sig figs, so the answer will be the 2 sig fig, that's 57 degrees Celsius. Easy peasy, got you an extra mark.